Thank you so much for joining. Shipbuilding, as you all know, is one of the most complicated manufacturing industries we have. But despite that, we're being demanded to build ships better, faster, with less rework. So today we'll see how using AI-powered digital work instructions can bridge that gap and make the complicated a little bit less complex. And the outcome we can see from that is increased worker accuracy, worker speed, understanding through using interactive 3D models as opposed to just 2D drawings, a better connection between engineering, planning, and the shop floor, and ultimately less disruption from engineering change. Yeah, without further ado, introducing our amazing speakers today. We have Craig Price, PLM implementation specialist at SSI. Craig's been in shipbuilding for over a decade and has great expertise solving the very problems that we're now using digital technology to enhance. And we also have Ellie from CanvasGFX. She's a chief product officer there with a background in design engineering and manufacturing, PLM, 3D visualization. And she's at the head of solving how information is shared between engineers and the shop floor and firsthand knowledge of how hard it can be. So without further ado, I'll kick it off to you, Craig, and enjoy the presentation.
Thank you, Greg. Yeah, a little more about my background regarding shipbuilding. My father spent over 15 years in shipbuilding as a pipe fitter, structural fitter, and supervisor with more than 10 shipyards under his belt. He passed on a lot of the stuff he learned to me as well as I started in the shipyard with him. And I myself have worked in 3 shipyards, from VT Halton Marine, now Bollinger, BA Systems, now Alabama Shipyard, and Austell, USA. And during my time in the shipyard, I worked in production as a pipe fitter and a supervisor, in planning as a mechanical planner, in IT as a business system analysis. I've worked in new construction and repair, and everywhere from the shop table to the assembly line to erection bay, waterfront, and even vessel completion yard with trough cards. So when it comes to organizing information to get from planning to production, it's a little bit of a passion of mine. So I'm excited about this project today. Some of the key points that we want to go over here is the current reality of shipyards. The goal would be the ideal shipyard, the shipyard challenges, the solution, which includes Canvas and SSI, a demo of where the solution is heading, and questions and answers at the end. So let's dive right into it. The current reality. What's the current reality of shipyards? So there's a couple of areas here that we've seen. Reliance on 2D drawings. A workforce who haven't grown up reading prints or even maps in 2D. It's becoming exceedingly difficult to teach or train them how to leverage legacy drawings, like schematics and diagrams for testing, or arrangement and details for installations. There's also frequent engineering change. Because of the nature of how rapidly technology evolves, ship owners often request system, ship-wide, or weapon system updates constantly throughout the build, engineering, and design of the vessel. Labor shortages. The education system has moved children away from blue-collar work for the past 30 to 40 years, with a push more toward college, which in turn has produced a lot less labor force in recent years. Tight production schedules. Because of the nature of shipbuilding and how long it takes to engineer, design, and build, production is often started well ahead of design completion. When engineering, design, and production overlap, it makes the production schedule for completion extremely tight. The goal that we're looking to accomplish. So what is a shipyard's goal to reach a future reality? Onboarding can consist of not having onboarding procedures or documentation in place to level up your workforce, and sometimes results in putting people in seats without direction for their tasks. Embrace digital technologies. Embracing digital technologies with interconnectivity makes your data easier to manage when compared to siloed systems. With information platforms like Shipbuilding PLM, you can collect engineering, planning, procurement, operations, and IT, inventory management, and production in a central location. Managing change. Change becomes easier to manage when it's incorporated into the digital thread rather than within siloed external systems. With Shipbuilding PLM, you can create change from production as a problem report, then engineering and design can review and start scoping change in an engineering change request, which then feeds an engineering change order to execute scope change, Within the ECO, you can manage your updated functional and modeled parts and drawings, as well as any updated production work packages, which in turn can update your digital work instructions. Deliver faster with fewer errors. Shipbuilding has a lot of concurrent activities. You can deliver faster with fewer errors when you have engineering change within your shipbuilding digital thread. With a shipbuilding specific digital thread, from your requirements connecting through your functional engineering to model detail design, it makes it easier to find information, allowing quicker access to information, which in turn can help with labor shortages and tight production schedules by limiting the amount of hours personnel spends searching for information. Transformation challenges. So what are the roadblocks to change in modern shipyards? Adopting new technology. Shipbuilding PLM is a source of truth that can collect vital information from external systems for people to access from a single location. With this example, you can see Shipbuilding PLM as a centralized information platform connecting engineering, design, planning, procurement, operations, production, and sustainment, including any additional software integrations that will benefit from information flow. Leveraging configuration managed 3D data. Functional products to detail design modeled parts exist within Shipbuilding PLM, and it can be configuration managed with workflows to approve parts from a preliminary state to released. You can start with requirements, driving your functional design. Then once your functional design and parts are approved, you can push them into ShipConstructor's project item list, or PIL, for your designers. When it makes the full circle trip back in Shipbuilding PLM, you can compare your 2D functional diagrams with your 3D modeled information. Upskilling the new workforce with legacy work instructions. With a new version of Shipbuilding PLM, we have digital work packages. These are to help bridge the gap for planning to production to leverage configuration managed engineering and design information to provide production what they need based on their work packages, work orders, and charge codes. The work packages leverage properties like stage of construction or process lane, workstation or work center, activity or charge code or bill, discipline, and much more. There's also the ability to add tasks or steps and leverage planning UDAs, or user-defined attributes, on your tasks, decoupling planning from design when the past planning leveraged ShipConstructor UDAs. The work packages can be placed in a new planning hierarchy, which allows for a single part to be placed in multiple work packages for various classifications of work. Rather than planning being limited with ShipConstructor's secondary product hierarchy, to potentially define an integrated master schedule for installation only, where the part can only exist once in a hierarchy. And then leveraging this digital work package, you can include production drawings created from ShipConstructor, as well as utilize a modern 3D DPN visualization to see exactly what you're installing. This digital work package can then be leveraged to then create digital work instructions.
Thank you, Craig. So now I'd like to talk a little bit about the solution that we've worked on in collaboration with SSI to create DWI to solve some of the problems and challenges and enable the current workforce to succeed using modern integrated technology. So first, I'd like to talk a little bit about Canvas Envision and CanvasGFX. So on the next slide, I have a bit of an overview of what Canvas Envision is. Canvas Envision is our flagship product. Essentially, it's a digital work instruction platform that allows users to author content and manage documents, in this case in a synchronized way with Shipbuilding PLM, using Shipbuilding PLM as a single source of truth, as well as the engineering data from Shipbuilding PLM in a synchronized fashion, and then offering a consumption experience to frontline workers that is interactive, often leverages 3D and other interactive content like video, interactive web elements, really giving people a clear concept of how to perform work in a way that allows them to onboard quickly. And along with that, of course, integration into other applications in the enterprise tech stack, PLM, MES, QMS. And then something I'm excited to highlight today is our AI and SDK capabilities. We see a lot of desire to enrich content to make it perform better on the front line, but the labor involved is a serious task. So leveraging AI as well as automation allows us to take some of that labor out. So on the next slide, just highlighting some of the value that Envision brings to its customer base and as well as partners. Some things I'd like to mention are just efficiency as well as value on the front line. So from a content creation perspective, we have quotes here from our customers saying they saw a 5 times increase in speed in generating their work instruction content, saving up to 80% of time. When we have especially our 3D data locked in design engineering, and we need to go through request chains, sending screenshots, creating obsolete and disconnected visuals, let's say, that can create a lot of bottlenecks and inefficiencies. So having direct access to 3D data from PLM, as well as other complementary data that we'll take a look at in this demo, that can just speed up the delivery of this content. And then on the execution side, especially in cases where procedures were previously, the instructions were either unclear or we see a lot of, let's say, quality or comprehension issues. We have a customer who said to us they were having this issue with improper installation. Every time the installation happened incorrectly, it cost them about $11,000. It could be even more in some industries, of course, depending on the hardware. But by introducing interactive work instructions at the installation scene, using, in this case, mobile devices, they're able to avoid these large quality events and improper installation procedures. So just a few examples. And on the next slide, I'll give you a glimpse of what Canvas Envision looks like. So just an example, using some shipbuilding data in collaboration with SSI, our 3D data is always interactive for the end user. It can be animated, it can be annotated. In this case, we're showing some of the animation capabilities to illustrate a sequence. So really using the 3D instead of creating an 18-page drawing with flat views, leveraging that 3D to create a clear picture and pull out the necessary metadata from the engineering model. So I think next we'll go to a demo, so to give a preview of the solution. So really at the foundation of this DWI solution is Shipbuilding PLM and the digital work package that Craig has championed and described. Some things I'll point out is this rich data set is really the fundamental piece of success here. So we have access to most of or all of the necessary inputs for the DWI. So things I want to highlight are the contents and the context. So on the 3D side, we have a collection of parts in the work package to utilize in the DWI. In the contents, we have additional rich data such as the sequence. I think importantly, the sequence can be defined on the work package level, as Craig said, not all the way back in design engineering and ShipConstructor, but in the work package itself. So change can be pulled, happen further to the right. We have a ship to and ship from data as far as the work packages, hardware is going to, parts are going to. So we know the kit list and the ship list data. And we have planner notes as well that can be applied to the DWI. And finally, the physical bill of material for things like fasteners that may be included in the instruction. Along with some of the data on the form you see here, we're able to create most of this DWI in an automated fashion. And because of the way everything has been done so intelligently on the shipbuilding PLM side, the 3D data can be collected and adjusted really right at the time of need. So a very flexible solution for change. So from there, I will go to the demo. So I'll share my screen. you should be seeing Shipbuilding PLM. And Greg, if you see otherwise, just shoot
that
a
way.
shot. Thank you. So I want to highlight this first. We saw some screenshots. So this is, again, that foundation that we're building DWI from that's been so well tailored for shipbuilding. So I'll point out, these are the parts that we're collecting. So we have the ability to create the necessary 3D data directly from the contents and the context parts. And in the contents, we have some really good information for DWI that can be assigned right here easily in PLM. So things like planner notes, and very importantly, sequence, task budget, as well as the ship to ship from information. And then something I also want to highlight, because we are also very enthusiastic on the usage of 3D data, is the fact that we have the interactive 3D view here. So if someone wants to assign the sequence, they have the ability to do that right from the work package. So we have a great foundation to build our DWI from. And from here, we're able to collect, let's say, all the properties from the work package and get right into our DWI. So I'll just highlight some things on how DWI or Canvas Envision connects to Shipbuilding PLM. So what we do is we have a synchronized copy. So we stay in sync with PLM. And if I jump around a little bit, apologies, but we have a change control managed Envision document in PLM. We have an embedded viewer with our DWI, and that's what I'll be showing you some examples of what that looks like. And then we are able to insert 3D data from PLM, save and check in the files. So we have this intimate connection with PLM. And then, I'll jump in to just an example of the output. So we saw where it starts from, how it's connected. This is what a DWI can look like created in Canvas Envision. So again, animations are something we support. So I put together just an example here of an animated sequence. We're actually pulling out that sequence data from the 3D model. So we're not typing anything in. We're really leveraging that PLM as a single source of truth and just creating an animated sequence here. Anytime we have, and then here again, we have materials list. This is pulled from the physical bill of material. And then here we have, again, a 3D view. So our 3D views are always interactive for the end user. Here we have all those context parts that are not part of this work package. They're all gray and opaque, so they're there for reference. And then here we have actually one of our interactive web elements, which is a synchronized bill of material, synchronized assembly tree associated with the task list. So some interesting things here. We can actually use this 3D view and this table to drive actions. So some things that we've done in the past are like ordering parts, contacting, let's say contacting planning, triggering actions in PLM. So really a digital first approach to interactive work instructions. And then from here, I'll show you a little bit about like how it's created, what it looks like for the end user, and we'll jump into the AI capabilities. So this is our creator. So when I started, I mentioned we create, we manage documents, and then we have this viewing experience. This is that creation EV creator. So we have a very friendly interface, very short kind of onboarding and learning curve, which is important if you're adopting new technology. And here we support multimodal, various types of media, of course, with an emphasis on 3D. We have a template approach to our documentation that can be reused, and the ability to insert interactive elements like this with a single click. So in this example, I've gone ahead and here I'm starting to work on the planner notes or the actual execution instructions. And where this is fine, I think, there's a lot more work to do to make this very clear and step by step. So from here, I'm going to jump into the AI section. Now, using the manual approach, of course, I can go in here and edit the 3D view. I have a very friendly interface to explode things, to hide things, to add annotations, but I can do this even faster using AI. So in this example, I have started from this template document. So I have these template pages, and here I have in this template some kind of hints. We call these prompt objects to create content. And if I zoom in, you can take just a look at the fact that I'm asking it to list all the parts installed in this step. And here I've gone ahead and I've inserted a 3D model related to this work package. And what I'm going to do is create something called a selection set, because what I want is everything in the sequence with the sequence one, the first step in the sequence. So in our AI assistant over here, we have Evie, our chat assistant. I'm going to just put in this command to create a selection set of all parts with the SSI sequence equal to 1 and name it 1. So without clicking whatsoever, it's going to go into this 3D edit mode and collect all of these parts and assign a selection set with the name of 1 according to this metadata property. And we let you see everything that happens so you can check your results, so to speak. And then we can actually take a look just to see the output. But we'll have a selection set. You can see selection set 1, and then all of these parts and assemblies have that property, and that's from Shipbuilding PLM. And the next thing I'll do is ask it to create this step-by-step page. So we took a look. This is my planner page. This is part of my template. And I have this command. It's a little wordy, so I copied it in, but create a planner page using the planner page, master page, and selected 3D view. Create a step page for the selection set 1 in the view, make the assembly with the name context ghosted and visibility on each step, for example, 1. And I could actually ask it to create the entire instruction. So I just did 1 for this quick example, but we can create, 10, 100-page documents, if you will, all using a single command. So this is a huge piece for efficiency. If we want to introduce model-based work instructions, but the labor is a challenge, using AI can help us get there faster. So I'll let it work and we'll come back. I can show you the end result because I've done this ahead of this webinar. But we get all of this with a single command, every single step in the sequence and its 3D views, as well as the complementary text. So we'll see it live, but it will apply that master page. It will manipulate my 3D view, and it will create the complementary text according to the contents of the view. You can see, and in this case, they're labeled. I could probably ask it to remove the labels, but this is the kind of thing we can do with AI. And as the solution is, developed, it's going to get better and better. So we're really excited about introducing this capability to DWI. So with that, I'll hand it back over to you, Craig. Thank you. Thank you.
All right. Thank you, Ellie. Just have one last slide here before we go to questions and answers. Just looking at a bit of a future state for how this could look from a design tool like ShipConstructor, connecting all the modeled information into Shipbuilding PLM, being able to organize information into a digital work package, which then could in turn, like Ellie was showing, feed digital work instructions for your production force. And then that work package could also connect to your MES and ERP systems, whatever those might be. This is just an example of some potential to where you could have a work package within your MES, which then could also connect into an activity or a job within your ERP system. And with that, I believe we are going to do a key takeaway wrap up here real quick. So the things that we looked at was the new workforce needs, adapting to change, digital thread for shipbuilding, and the value of digital work instructions with AI. I believe we're over to questions and answers.
So Craig, I see one in the chat about the PLM software and if it's related to ARIS. Do you want to take that one?
Yes. So, Shipbuilding PLM is built on top of ARIS Innovator, similar to how ShipConstructor is built on top of AutoCAD. So we're leveraging that as an underlying platform.
And then we have a couple of pre-submitted questions, which I'll toss at you guys. Question, which AI features are practical today, and how do you ensure their outputs are safe to use in production?
Yeah. So where we're focused is really on content creation. Some might refer to it as generative AI. And what we really do is our AI solution has special knowledge on how to use our APIs. So what it's really doing is, instead of you having to write a script to do all these things, it's taking your natural language and essentially generating that script on the fly. And the way that we see it is, it's still a human in the loop process. We expose the detailed step-by-step thoughts and outputs so there you can still have a human check. So that's the stage we think we're at. We're not ready to hand the keys over to AI completely, but we see it as a huge accelerator. And yeah, so I think it's really that human in the loop stage that we're at. And as it becomes more fine-tuned, I think we'll begin to all adopt it and use it more extensively.
Another question we had was around, how do digital work instructions stay in sync with our PLM and ERP so changes flow through without manual rework?
Yeah, so I think there's a few things. So we connect, Canvas Envision connects directly to PLM. So changes are always synchronized and managed and change controlled within PLM. And then furthermore, we are creating this relationship directly with the work package and the ability to update the documentation in conjunction with changes to the work package. So they're highly synchronized and connected. And then as far as like what I might refer to as federation and exposing those documents elsewhere, because this is a digital first approach and we're not, rather than paper or paper on glass, we have the ability to provide the most up-to-date version at any given time. So updates can be pushed and applied in real time with appropriate controls around them.
Craig, maybe I'll toss this next one to you. The question was, when or does this mean that we can skip creating a traditional drawing if we have digital work instructions?
Yes, I think that's an interesting idea. I think that that's a good one to assess to see what drawing outputs that you might be putting out currently, like arrangement drawings, that might be a good candidate for something similar to a digital work instruction. If those arrangement drawings are typically being broken down into smaller pieces of installations instead of the entire drawing, it might be worthy for consideration. It may not fit every single use case at this time, but there are a lot of ones that I think are potentially worth assessing to see if you could, as far as your business goes, if you don't have any other requirements that you can't get from a digital work instruction, I think it's worthy of an assessment to figure that out.
Another question was around kind of the shop floor, and the question was, what's the best way to deliver instructions directly to individuals on the shop floor?
I think there's a two-part answer. I think we see a lot, very common, like PCs or tablets. That's what we see as far as like a delivery, the interface. Oftentimes, very often, we integrate with an MES or an ERP system to orchestrate and deliver this content, especially because it's controlled within PLM. That makes this, easy to connect to the enterprise tech stack. So I think two-part, there's orchestration and then delivery on device, but having a shared PC workstation or a personal tablet are both options that we see in practice.
And then the last question I have from the pre-submitted ones was, how does this approach accelerate engineering changes before they impact the yard schedule and budget?
Yeah, that's an interesting one. I think that there are some additional capabilities in our digital work package to where you can see engineering changes happen in real time. So if an engineering change comes over from ShipConstructor into Shipbuilding PLM, when you already have your work defined and planned in your digital work package, those content items within, both content for those tasks as well as the drawings themselves, the entire line will highlight red. You'll get a little additional notification on it for colorblind. There's also an icon, but you look at it and you can see that there's a change to your work package. So then the planner has a decision that they can make, whether to put a stop work on that particular task or to then revise the work package to be able to incorporate change with whatever that change order might have been. And then once that's all redone, then you can essentially push that change into your digital work instructions. So you have visibility to see what's all there. And then in a fully integrated approach, like I kind of showed earlier, if you have it connected to MES all the way down the line, you can get that information rolled back into your PLM to see what your production state is. So that engineering can see if something's already been started on the field before they decide to make a change on it.
Great, thank you so much. That's all the questions that I had from the pre-submitted ones, and I don't see any additional questions in the Q&A. So I think we're safe to leave it there. Thanks again so much, Craig and Ellie. This is an exciting topic, and we're happy to share the development that's going on in it and what's possible now. For anyone that would like to review this later, the recording will be sent afterwards. And as I mentioned, if you'd like the slides, please reach out individually and we can send them to you. And lastly, I know that Craig and Ellie are always open. Their emails were in one of the last slides. Feel free to send them any questions directly, and I know they'll be happy to get back to you. So with that, leave it there. Thanks, everyone.
Thank you all.
Thank you, everyone. Have a good day.